In this video, we're going to be talking about math induction. We're going to be doing two examples on this particular type of question. Use the principle of mathematical induction to verify that for n, which is any positive integer, 6 to the power of n minus 1 is divisible by 5. So we want to prove by mathematical induction that this is divisible by this. So we're going to be doing two questions on this type of mathematical induction. So let's get underway. So what you want to do is follow three steps. Okay, if you have not watched my previous video on the introduction to mathematical induction, then I would link it up on the right side of your screen. Okay, so there are three steps whenever you want to solve any mathematical induction question. The first step is to prove that n is equal to 1. The second step is to assume that n is equal to k. Assume. So the first one, we're proving that n is equal to 1. The second one, we're assuming that n is equal to k. And for the last and final step, we would prove that n is equal to k plus 1. Okay, so these are the steps that we would follow in solving this question. So let's do the first one. So we want to prove that n is equal to 1. So this is the value that we have, 6 to the power of n minus 1. So we want to prove that n is equal to 1. So what we're going to do is we're going to put 1 wherever we see n. So over here we have 1, so we have an n, so we put the 1 there. So that's the 6 to the power of 1 minus 1. 6 to the power of 1 is 6. 6 minus 1 is 5. So now this would be true if the answer that we got is divisible by 5. Now 5 is divisible by 5, that would be 1. So it means that n is equal to 1 is correct. Now when you are proving for n is equal to 1, if your answer does not meet the requirements, then it means you cannot go further. Alright, if n is not equal to 1, it means you cannot go further. That is why you have to prove that n is equal to 1. So the next step, we are going to assume that n is equal to k. So we can take this out. So we want to assume that n is equal to k. So wherever we see n, we simply put k. So this is 6 to the power of k minus 1. Now we need to equate it to something. So we're going to equate it to 5m. Now the reason we are doing this is because the question says that 6 to the power of n minus 1 is divisible by 5. It means that whatever answer we get, we're going to be able to divide that answer by 5. But we don't know our answer, hence we're using m. You don't have to use m, you can use x, but that's too common. You can use, and you can use whatever letter that you want because it's a variable and it represents something. But 5 here is simply telling us that our answer is divisible by 5. So if the question says it's divisible by 11, this here would be 11m. Okay, so let's carry on. So now we have this. So we're done with this bit. So now we want to prove that n is equal to k plus 1. We want to prove that n is equal to k plus 1, meaning that wherever we see n, we simply put k plus 1. So we have an n here, so we have 6 to the power of k plus 1 minus 1. Okay, as simple as that. So now what we are going to do is we're going to name this equation 1, and you would understand why we do that in a bit. Now from the rule of indices, it states that if we have 6 to the power of k plus 1, we can write this as 6 to the power of k multiplied by 6 to the power of 1. Okay, this is basic rule of indices. It states that if we have a to the power of x multiplied by a to the power of y, this is going to be a x plus y. Alright, x plus y. So this is how it is. So it's exactly the same thing here. So this was our original equation, then we just converted it to this, hence this. So that's just indices. Okay, so we have 6 to the power of k multiplied by 6 to the power of 1. Then we have minus 1. Okay, so we're done with this. Alright, so now the reason for this equation is that we're going to form a new equation from this. So we can say from equation 1, what we want to do is make 6k the subject of formula so that we can replace this 6k over here with what we make. Okay, that's the reason why we had to expand it to this format. So we have 6k minus 1 equals to 5m. So in order to make 6k the subject of formula, we simply take 1 to the other side. So this is going to be 6k, 6 to the power of k, equal to 5m plus 1. Okay, so we simply took 1 to the other side. So 6k, 6 to the power of k is equal to 5m plus 1. So now we are going to substitute 6k into this equation that we have here. So wherever we see 6k, we're simply going to put 5m plus 1. Alright, so 6 to the power of k, we put 5m plus 1. I apologize for my handwriting. Nevertheless, it's legible enough, I think. So we have this, so this still stands, so multiplied by 6 to the power of 1 minus 1. Okay, so we have this, so it's as simple as this. So now we can carry on from here. So what we're simply going to do is open up the bracket. Now 6 to the power of 1 is 6, so this is simply saying 6 multiplied by 5. So 6 multiplied by 5 is 30m. 6 multiplied by 5m is 30m. Then 6 multiplied by 1 is 6. So we have minus 1. Okay, so now we've opened the bracket. So 6 minus 1 is 5. So we have 30m plus 6 minus 1 plus 5. Alright, so now what we want to do, it says we need to prove that this is divisible by 5. So we need to make sure that 5 can go in this and this at the same time. Now we know that 5 can go in 36 times. So this would be 6m. And 5 can go in 5 as well, just once. Okay, so now because it left a whole number, it means that this is correct because we are able to have 5 outside. Okay, we're able to bring 5 outside of this. So it simply means that 6 to the power of n minus 1 is divisible by 5. So you can write it is true, or we have successfully proven that 6 to the power of n minus 1 is divisible by 5, and this is your answer. So this is how you will solve a question like this. But this question is relatively simple, so let's go over to the next one where we'll solve something a bit more complex. So this question, we're going to be doing something similar to the last one, only it's a bit more technical. So it says prove that 11 to the power of n plus 2 plus 12 to the power of 2n plus 1 is divisible by 133. So we still have 3 steps. The first step is to prove that n is equal to 1. The second step is to assume that n is equal to k. And the final step is to prove that n is equal to k plus 1. So let's start with the first step. We need to prove that n is equal to 1. So wherever we see n, we're going to put 1 inside of it to see if it is true. So 11 is equal to 1 plus 2 plus 12 is equal to 2 multiplied by 1 is 2 plus 1. Okay, so we have 11 to the power of 3 plus 12 to the power of 3. Okay, so 11 to the power of 3 is going to be 1,331. Okay, then 12 to the power of 3 is going to be 1,728. So when we add both of these together, the answer needs to be divisible by 133. So if we add it together, we have 3,059. So in order to know whether n is equal to 1 is correct, we need to divide this by 133. And if it gives a whole number, it simply means that it is divisible by 133 and n equals to 1 is correct. So this divided by 133 gives us 23. I apologize for that, but it gives us 23. So n is equal to 1 is correct. Now, if n is equal to 1 is not correct, it means you cannot go further. Like I said before, you cannot go further with your solving. Okay? So now let's go over to n is equal to k. We need to assume that n is equal to k. Okay, so n is equal to k. Okay, it means that wherever we see n, we're simply going to put k. Now, we're not proving that n is equal to k. We're just assuming that it is. So wherever we see n, we put k. So 11k plus 2 plus 12 to the power of 2k plus 1. Okay, now we're going to equate this to 133m, just like we did in the other question. So again, the logic behind this is simple. M is an integer. Alright, so it means that whatever this is going to be divisible by 133. So no matter what this is, as long as an integer, it means that this is divisible by 133. Okay, so now that we have that out of the way, let's now prove that n is equal to k plus 1. So the same process, wherever we see n, we simply put k plus 1. So we have 11k plus 1 plus 2. Okay, plus 12 to the power of 2k into k plus 1 plus 1. Okay, so now let's just open everything out. So we have 11 into k plus 3 plus 12 into 2 multiplied by k is 2k. 2 multiplied by 1 is 2. Then we have plus 1. So now we have 11 to the power of k plus 3 plus 12 to the power of 2k plus 3. 2 plus 1 is 3. It's as simple as that. Okay, so now let's go over to, it's just like what we did in the previous one. Alright, so now we have 11 to the power of k plus 2. Let's call this equation 1. Now we want to make 11 to the power of k plus 2 the subject of formula, meaning that we're going to take all of this, 12 to the power of 2k plus 1, to the other side. Okay, but if we look here, we have 11 to the power of k plus 3. And remember, the reason why we do this is so that we can replace whatever we have here with this. So ideally, what we want to have here is 11 to the power of k plus 2. So it's very easy for us to replace this when we take it to the other side. This is going to be 133m minus 12 to the power of 2k plus 1 if we make this the subject of formula. But we have 11 to the power of k plus 3. So what we can write is, obviously we know that k plus 3 is the same thing as k plus 2 plus 1. The exact same thing. Alright, so what we have done is we have brought out k plus 2 and it now looks like this. So therefore we're going to have 11 to the power of k plus 2 plus 1. Alright, we're going to have that over there. So let's just write that. So now we have that 11 to the power of k plus 2 plus 1. So it means we can write this as 11 to the power of k plus 2 multiplied by 11 to the power of 1. Because at the end of the day, it still comes back to this. And at the end of the day, it still comes back to this. Okay? So this is then plus 12 to the power of 2k multiplied by 12 to the power of 3. So now that we have this sorted out, what we want to do is make this the subject of formula and replace it with this over here. Okay? So now if we want to make 11 to the power of k plus 2 our subject of formula, we simply take this to the other side. So it's going to be 133m minus 12 to the power of 2k plus 1. Okay, this goes to the other side, it becomes negative. So minus 12 to the power of 2k plus 1 minus 12 to the power of 2k plus 1. Alright, so now that we have that sorted out, we multiply everything by 11 to the power of 1. 11 to the power of 1 is 11, so we can just write that. Then we have plus 12 to the power of 2k multiplied by 12 to the power of 3. Okay, so we have this. Alright, so now let's carry on. Now we simply expand the bracket. 133m multiplied by 11 is going to be 1463m. Okay, then we have minus 12 into 2k plus 1. Everything multiplied by 11. Then we have this plus 12 to the power of 2k multiplied by 12 to the power of 3. So like what we did in the previous question, we are going to take the positive side over here and the negative side over here. That's what we're doing. We're just taking the positive, bringing it closer to this, and taking the negative over there. So 1463m plus 12 to the power of 2k multiplied by 12 to the power of 3 minus 12 to the power of 2k plus 1, everything multiplied by 11. So all I have simply done is rearrange this. It's still the exact same thing as this. All we did was rearrange. Alright? So now we're going to expand this one, then we'll see what happens from there. So this is 1463m plus 12 to the power of 2k multiplied by 12 to the power of 3 minus 12 to the power of 2k, let's expand this, multiplied by 12 to the power of 1. So it's the simple indices, or it's the same indices that we have been doing before. We just expanded this, okay? Everything multiplied by 11. So now I see something common in everything, which is 2k. But before we bring out 2k, let's expand this. So this is 1463m plus 12 to the power of 2k. So now, if you notice, I have removed the parentheses, and now everything is multiplying each other. So 12 to the power of 2k multiplied by 12 to the power of 1 multiplied by 11. I only remove the brackets. So now I see that 12 to the power of 2k is common. So what I would do, 1463m. Okay, so now what I'm going to do is bring out 12k. So we have plus 12 to the power of 2k rather. Okay. So now, if 12 to the power of 2k goes in this, we're going to have just 12 to the power of 3. Because 12 to the power of 2k would cancel this out, so this is all we would have. Now, if 12 to the power of 2k goes here, we're going to have 12 to the power of 1 multiplied by 11. Because 12 to the power of 2k has cancelled out. Now, our work is getting simpler. So we have 1463m plus 12 to the power of 2k. Now we're going to work with what we have in the bracket. So 12 to the power of 3 is 1728 minus 12 to the power of 1, which is 12 multiplied by 11, and that would give 1596. 1596. So now we have this, okay? So this simply means 1463m plus 12 to the power of 2k multiplied by 1596. Now, it doesn't seem like there is any other thing that we can do. So we can look at the question, and it says this, we need to prove that this is divisible by 133. So let's see if 133 can go in all of this. All right. So we put 133 outside. So let's see if we can go in this. This is 1463. So 1463 divided by 133 will be 11. So we can see that this one successfully goes. So we have 11m. Now let's see if 1596 can go in 133. And yes, it can. It gives us 12. So 12 to the power of 2k multiplied by just 12. Alright, so this is our answer. But we can go further and write this properly. 133 into 11m plus 12 to the power of 2k. Now, I'm sure that you know there's an imaginary one here. Alright, any number would have an imaginary one as its power. So that means this is 12 to the power of 2k plus 1. We can write it like this. Okay, so now this is our answer. Because this is an integer, any number that would be here would be an integer. It means that 133 can go in our original question, meaning that this is divisible by 133. So that will be all for today's video. I hope you understood everything, and if things were still not clear, you could rewind and watch it till you understand. Alright, I'll see you in the next video by God's grace. Take care.